Good evening. This is Eastern PA Weather Authority meteorologist Bobby Martrich, and I want to go through a little bit of a discussion this evening, a little video discussion, since this was so popular before. It's also going to save me about at least an hour of time to go through a written blog that some people don't like reading on a Friday night anyway. But I wanted to do a little discussion and explain things from a synoptic standpoint of what's going on and why we are not able to commit at this time to a storm threat next Wednesday. If you haven't heard about it by now, I mean, you must be living in a rock. But I mean, there is a storm threat next week at least. We'll say there is a threat, and it's a legitimate threat. But at this point in time, we're kind of sitting on the fence just until we see some more things come together and can make a more accurate determination of what's going to happen next Wednesday. And we don't think right now that's going to happen until Sunday, and we'll show you why. First of all, this is the blog that we put up on our website. Was done by our Northern New Jersey forecaster, Frank Paparato, and he did it on February 22nd, which is pretty amazing because at that time there was no storm shown on any models, yet he put a blog up that we're watching this time frame. This is something we talked about in our back channel groups within the team itself. We have a team of 6 individuals, very talented individuals that make up our support staff, and we were talking about this period actually longer than this blog was written, probably from the middle of February. But there's some things that were lining up at that time that we saw that could produce a big storm, and lo and behold, now we're dealing with one, or at least a threat of one for that time frame. I want to jump into the GFS from today, and which will show you exactly what we're looking at here. This is the GFS at 12Z today. Now, I want to show you what's going on here. This is the storm itself as it's currently positioned. This is sitting over the Pacific Ocean here. Now, the important part about this is, this is what I want to explain because a lot of people don't understand how this works. These models, you have the GFS, you hear us talking about the GFS, the Canadian, the European. This is the GFS model, but all these computers are supercomputers. That's all they are. They're computers that will assimilate what they think is going to happen down the road, just like a meteorologist can do that. Now, we take this data that each model is showing. We understand the strengths and weaknesses of each one individually, and then we'll make a determination of what makes the most sense based on what each one is showing individually. But what these do, they're supercomputers that collect data. And where does it get the data from? The data is from observation stations. You have observation stations all over the country. Here, I'll show you. Boom. See all those dots? There's all these dots. There's hundreds of them. Now, these are just the major ones. There's actually secondary ones that are in between these. But these are major reporting stations, all those dots there. Now, what these do is these dots represent Allentown, Philadelphia, Scranton, Reading, major reporting stations. Okay, there are some in between ones that also collect data, like up in Stroudsburg, down in Quakertown, Doylestown. Those are some in between observation stations that will still collect data as well. And what they do is they'll take not only the surface conditions and report the surface conditions hourly, they also do conditions of what it's like at each layer of the atmosphere, and it'll do temperature, it'll do wind, it'll do barometric pressure. There's a lot of things, humidity, a lot of things that go into that, and all that data is then collected every hour and ingested into these supercomputers. The supercomputer will then take that information and basically come up with a forecast based off with all that information. So as it changes, and that's why these runs change, they come out every 6 hours or 12 hours, whatever the case may be, it's getting fresh data integrated into the runs. Now, with that being said, the reason I'm saying that is because this system sitting out here, as it's sitting there right now, get rid of this nonsense, this system as it's sitting out here right now is sitting over water. So where's the observation stations? There isn't any. You get a few buoys out here that are kind of close, they're real close here, might be picking up on some of it, but you're really not getting anything to measure, accurately measure this system itself here. So we have to wait till it gets on shore. When's it going to do that? Well, now we're looking at, this is Saturday night, finally coming on shore, Saturday night. This is a few hours later, in the middle of the night, Saturday night. Now it's been on shore for about 6 hours. It's sitting over here in southwestern Canada, and as you go on time here, now moves into northwest Montana here. Now the whole point is here, it's picking it now. It's over land. Now there's observation stations between here and here that it has done 12 hours, actually at this point 15 hours of data that has collected into this to measure the system itself. And why that's important is, by the time Sunday afternoon rolls around, these models should be able to pick up on a solution definitively of what's going on because it had that fresh data integrated in the model. Okay, not spending entirely too much on that time on that, but I just wanted to explain that to you so you understood why we can't make a call until Sunday afternoon at the earliest, because we won't have any of this data ingest. These models can be shown to be absolutely haywire, showing a major blizzard for parts of the interior Northeast. It could easily just be one of these deals where it's completely sheared out and goes out to sea. I don't think it is the case, but you're usually not that far off. But there's a difference in model spread right now. So you have some models having it do this, like the GFS. Watch what this does. Actually, I'm going to put this in motion, make it easier. Watch what this does. It comes off the coast of 12Z, and boom, you got a blizzard here for eastern PA, central PA, south. Places basically they got shafted all year with snow are now dealing with a boom, big time blizzard. The Canadian model showed something very similar to this. The European model last night showed something like this. Today is a little bit further south, but it still does get snow up in this area. But the concentration was more South Jersey, Delaware, Maryland, which just get absolutely crushed on the European model. And there's a few other ones that are close to that solution as well. So they're pretty much split on what's going to happen. Some have it going up here like this, some have it going out like this, and I think either way, no matter what, I think it does start to turn north like this. But is it going to be right here where it clobbers the Mid-Atlantic, or is it going to be further out to sea when it goes like this? And if you look at the 18Z GFS, it did that. Now this is a little bit different, and watch what this does. Goes off the coast and doesn't come north. It starts going north, but it's too late. Look where it is, way out to sea. And then, of course, it blows up, stalls, and then drifts east. Everything is doing that, too. They're all coming up the coast, whether it's here or here. They're all coming up the coast, come to a point, stopping, stalling for 6 to 12 hours, and then finally drifting east. And it's doing that because of the strong block here. And I want to show you this synoptically, what you need to be looking for in future runs. This weekend, if you're one of those guys that like to stay up and watch these model runs, what we're looking for. This is the 500 millibar map here, which is easier to show you the features in play here. Those other two were just the surface maps. These are surface reflections. This is 500 millibar. This is the 500 millibar of today's 12Z GFS. Feature number 1 is our storm system sitting right here. Feature number 2 is a trough that is now over the northeast, and we need to kick out of here. The quicker the better if you want a snowstorm in the northeast. Feature number 3 is this large area of high pressure sitting right here. This will actually funnel the cold air into the system if there is a storm off the coast here. So it'll help keep it cold and keep temperatures cold enough for it to snow on these interior, at least for interior areas, northwest of 95. System number 4 is this upper level feature sitting right here over the Great Lakes. This needs to interact with this so that as this is heading off the coast, this will actually kind of lasso this thing back into play here. And I'll show you what I mean here as we go on the time here. These two will actually phase together, or attempt to phase together. You see they're interacting now. This feature, see how it looks like a rope. It's almost like this feature saying it throws a rope at it or around a cattle's neck and tries to wrap around it. See it? Wraps around the entire system. So this is trying to phase with this system here, and when it does, this acts like a lasso. Like I said, when you're trying to hog tie something, it'll pull it backwards. Once it does that, see, look, it's pulling it backwards, and it pulls it north and wraps around it. Now it's completely captured. Look at this thing just feeding in here, and it's completely wrapped around it. All this does here is acts to pull it up and stall it. Once it wrapped completely around, it stalls, and then it finally kicks east. The 5th feature I wanted to speak of real quick, and I'm not going to spend too much time on this one, but there's a system out here in the Pacific Northwest, and this is actually part of the key also. If this thing stays intact and digs the trough here further south, it will actually help to increase the ridge. You can see the ridge here, so I'm drawing it. You got trough, and you get a ridge, and then you got a huge trough here. The bigger this ridge is, the more this system digs south, and the better likelihood it is that it comes up the coast. Okay? I look at the 18Z GFS that we showed before. It's way east. Why is it way east? Well, very simple. Here it is. Now I want to look at this at the same. I'm going to put these side by side, same time frame. This is on the 12Z GFS. Look where it is, sitting over Tennessee. Same time frame on the 18Z GFS. Whoa, South Carolina, way east of where it was. And why is that? Well, like I said, each model we look at has strengths and weaknesses. This model does some things a little bit differently. One, it keeps this trough kind of hanging in here in the northeast. It doesn't kick it out. So there's still a trough here. This, by this trough still being here, it is shunted further east. This is a model bias of the GFS to progress things along too quickly. It has a tendency. This model has a tendency to want to take things into the west coast and get them as quickly as possible from the west coast to the east coast. That's what this model does. Could it be right showing that? Sure. I'm not saying it's definitely wrong, but it has a tendency to do that, and it doesn't really fit the pattern for this thing to really race this southern stream energy way out in front like this. The northern stream energy is still over here, but it's not able to interact with it until it's too late because it's way out in front. So when it finally does interact, and here comes a lasso, again like we talked about before, it's trying to get it, but this thing's jumping way offshore already. It's trying to say, whoa, wait a minute, come back, and then look at it. Well, in the future, look, it finally gets it, throws a lasso out around it, captures it. See there, you can see that perfectly. See how I just grabbed it and it wraps around it. Perfect, beautiful. But the problem is now it's 400 miles off the coast. It does capture it, does stall it, just like it did on the 12Z, but instead of it being here like you want it, it's all the way out here. So it's a storm for the fishes. Okay, you see the big difference there? So anyway, there's a lot of different scenarios, different possibilities. The different models are showing different things. The point is, we're not going to be able to have a better idea of what's going to happen with this system until it comes on shore. And once it does, and it's able to be sampled Sunday afternoon, we should have a better idea, see the models come together on a solution. We're still 50-50. If you go to our website, and you guys should really take advantage of this. This is our website here. It has such a plethora of information on here. We redid the format of everything on here, where everything's easy to find. We have drop-down menus here. There's everything you're looking for you can possibly find in weather is on this page. Snow totals are on the scrolling marquee for different locations throughout our region. Got a little spring countdown timer on there. Our daily forecast is where you can find every day, just like you would on one of these apps for the Weather Channel or AccuWeather or whomever. Of the whatever the forecast is for the upcoming week, you can do that here too. You just have to pick your region. We got northeast, east central, southeast PA, north central and south central PA, and northern and southern New Jersey. Where those are forecast regions, and all you have to do is just click on any particular region you want to see, and on each one of these, it will give you the current time, current conditions, our 5-day forecast, and then a forecast discussion right below it that explains this graphic here in more detail. So, and this will happen in every single region, just going to get you guys that are new to the site to understand that this Facebook site supports this website, and that this is actually the means of the business. So I do encourage you to go to that site. And our weather alert map section of the site is actually where we put up any calls that we make as far as amounts of snow and things like that. Now we did go outside the box this time. We have a scenarios map up here that explains the different scenarios of what could happen, and it says clearly here, as of March 1st, we favor no storm track over the other, remain 50-50 on this scenario of either going like this or like this, and we're waiting for model consistency, and that won't be until probably Sunday afternoon before we get a better handle on this. So please be patient with us. Just want you to understand what we're looking at, and hopefully you have a better idea of where we're coming from and why we can't commit one way or another, even though some out there in the media have gone very aggressive. We're going to kind of take this one day at a time and we should have a better handle on them by Sunday afternoon again. So, if you want to stay tuned with us this weekend, we're still going to follow the model runs, but again, we're not going to be able to commit to anything until at least Saturday afternoon, maybe not even until Monday. But right now, this is what we're looking at, and you guys have a great evening, and stay tuned to the Facebook page for rapid updates. Eastern PA Weather Authority meteorologist Bobby Martrich, and have a great night.